Hello students, now come to the last question of this question number 1. Construct the following quadrilateral, or you can say last question of the exercise also. Rhombus BE and D. Okay, rhombus BE and D. So I have drawn a rough sketch here. Let me draw the rough sketch here itself. It is rhombus. So we know that all sides are equal like this. Okay, rhombus. So B, E, and D. Here BN means this diagonal is 5.6. This is given 5.6 centimeter. And DE, this diagonal, is given how much? 6.5. So how we will construct now? See, in this figure we have only the measurements of diagonal and there is no measurement of the side is given. So how we will start our construction? See, look at here. Let's take this diagonal DE. So we will have our line, as I already told you, you will draw the line so that you can measure it. So 6.5 first. Let me draw 6.5. 6.5, this diagonal DE, 6.5 centimeter. Now, rhombus. You know that in a rhombus, diagonals bisect each other. It means this portion of diagonal is equal to this portion of diagonal and this portion of diagonal will be equal to this portion of diagonal. They bisect each other. Okay, so we have to find a perpendicular bisector here. So what we will do, we will take our compass just greater than the half of the measurement. If this is the diagonal DE, or you can say line segment, just by a rough estimation you can take more than half of the measurement with the compass and try to draw an arc mark. Suppose here you put an arc and without changing the compass place the pin here and put an arc mark here also. Same way on the other side also, in this way also. So from D here you will get arc mark and from E here you will get arc mark. Is that clear? Now draw a line perpendicular bisector in this way. Let me put the arc mark like this. Okay, so this is the perpendicular bisector. Now DE is the diagonal of this rhombus, and as I told you that the diagonals bisect each other, so half of the DE is here and half of the DE is here. Now we need to find a diagonal BN such that half of the part should be above DE and half of the part should be below DE. Means 5.6 should be, we have to make it half. So by calculating or simply by calculation we can find out what is the half of 5.6 and that you can put an arc, but it's not a correct way of doing. So what we will do, without hesitation, measure 5.6 here. You will measure 5.6, place the pin here and draw a line. So suppose it will cross somewhere here. This point from here to here it is 5.6. Is that clear? What I want to say? You got a length 5.6 centimeter from this point. But see, from this point it is not 5.6, it is half of the 5.6, as because the diagonals bisect each other. So half of the 5.6 will be below DE, that is from here. Suppose let's take it is as a O, intersection O. So ON is half of BN or OB is half of BN, means this is equal to this, means OB equal to ON. And OB plus ON equal to 5 centimeter. But right now here O, let's take O and this point is 5.6 centimeter, but we need to take half. So now just imagine this is our line segment, this point and this O is our line segment, and try to find the perpendicular bisector here. Just like here we did, what we did, we took more than half of this line and put an arc mark here and arc mark here. Now place the pin in this way on E. Now put an arc mark here and put an arc mark here. So we got the intersection point as soon as we find our two intersecting point, draw a line which will be the bisector of these two, perpendicular bisector. Is that clear? So these are the half of OD means half of DE, this one, this part. So in this way here also, now it is 5.6. If we find the perpendicular bisector of this line, then this part will be half of 5.6. Now place the pin here, take a measurement more than half of this line and put an arc mark here. Sorry, from here it will like this, and from here it will like this and like this. Now from this point you will draw like this, so it will cross like this, and from here also like this you will cut, so it will like the intersecting point you will get. Now if you join these two intersecting points, what you are getting? You are getting half of this. This is 5.6. You are getting 5.6 here, 5.6 here. Is that clear now? This is our vertex B. Why? Because from O to B is half of 5.6. So from this to this is half of 5.6. This will be our required vertex B. This one. Now from B to N is how much? 5.6. Already it is 5.6 is there. You will measure it. Place the pin here and try to draw a 5.6 here. So from there you will try to draw an arc here in this direction. So somewhere here you will get 5.6. This is our required point N. This is our point. Now join this line. Sorry, this one also, and this one also. This is our required rhombus. This is 5.6. Is it clear? Once again, let me see you. First draw DE. In a rhombus, the diagonals are perpendicular bisector. So in D, I try to find the perpendicular bisector. From E, I put an arc here and here. From D, put an arc here and here. So joining these two intersecting point, I got the perpendicular bisector. So this is the bisect. Half of DO and OE is equal. Now I need to find half of 5.6 above O and below O. But I don't know the measurement. So what I took, from this point, I draw a 5.6 arc here. So this is the 5.6 line segment. This is the 5.6 line segment, 5.6. From there, I took the bisectors. So this is the half of 5.6. From here to here and here to here, this is half of 5.6. From this point, this is the half of 5.6 I already got. Another half I need to find here. So from here, I will draw an arc of 5.6 here. So it is complete 5.6, means half of 5.6 is here and half of 5.6 is here. So this is our required rhombus. So I hope you have understood this one nicely. Thank you.